Hello everyone, and you're all very warm welcome to this tutorial for the PMDG Boeing 737 for Microsoft Flight Simulator. I'm Emmanuel, I'm a member of the PMDG tech team and a real-life Boeing 737 pilot. In this tutorial I'm going to show you how to program the flight management computer. The way I'm doing it in this video is the way it's done in my airline, which is sort of the manual way of typing everything in. And I will do another separate video where I'm going to show you how to uplink some of the information and how to play with some of the data link functions in this FMC. Alright, so we'll start off in the main menu. We'll enter the FMC. We'll check the data in here is current. We're in a 737-700. It got a 24K engine rating. Note that if you're sitting, for example, in the Boeing business jet, it might have a different engine, a 27K engine. We'll check that the IRAC is up to date, and from there on we'll head for the position init page. We'll copy the GPS position from the position reference page 2, which you can access with the next page and the previous page button, and you're going to paste that into the set IRS position prompt. From here we're heading onto the route page, entering our departure airport, Echo Golf Sierra Sierra, and our destination airport, Echo India Delta Whiskey. Our flight number is the Romeo Yankee Romeo 7 Echo Golf. And we are going to depart on runway 22 here in Stansted. Next, go to the departures arrival page, click on departure. Runway 22 is already pre-selected, but we'll just click on it again because then it filters our standard instrument departure to show us what we're actually looking for. Over here, on the second flight plan page, we can see we are filed for the Utava 1 Romeo departure. Next page, Utava 1 Romeo. Go back to route. Next page. Then we're proceeding via Quebec 75 to Buzzard. Then Tango 420 to Trent VOR, and I'm going to show you a small feature here. If you have one airway in and then you link up with the second airway, you can just turn to the second airway without actually inserting the waypoint. So Upper Lima 28, that's in, and then it is going to insert automatically the first intersection of the two airways from your present position. Be aware that there are a few airways out there in Europe and in the world which have several intersections, so you might not necessarily get the waypoint inserted that you're looking for, so do cross-check it with the flight plan. From here we have Tango 420, Trent VOR, then Upper Lima 28, so that's correctly inserted, and then we're going via Mike 145. Again, check here, it's waypoint Leldo in between, and we're going to Baxo on this airway. Right, that's our route in. Now we're going to select departures arrival, Dublin arrivals. We're expecting runway 28 left, and it's going to be the ILS approach. That's up here. And we're filed for the Baxo 2 Lima arrival. Next, go to route. Check there is no discontinuity inserted in here. Click activate. And then we head on to the init ref, index, performance. Note that this page is automatically going to pop up when you press init ref when the IRS is aligned already. However, as you can see, our IRS is still aligning, so we have to select it manually. From here we're going to insert the performance information, cost index 6, as we can see up here. Our reserves, located down here on the flight plan, are 1.9. Note that you always round the reserves up. If we'd say, for example, you have 1,901 kilos standing over here, you would round it up and insert 2.0 as 2 tons. That's because we always want to take this additional safety margin there. Zero fuel weight, 51.5. We're planned at flight level 340. The cruise wind, the average wind here, 93 degrees, 35 knots. The deviation from the standard atmosphere at the top of climb is minus 7 degrees, so it's 7 degrees colder. Therefore we have minus 52 degrees at, or rather subtract another 7 degrees, that gives us minus 59. If you're wondering that, hold on, 52 minus 7, that should be 45, then yes, you're right, but keep in mind we're talking about negative temperatures here, so minus 52 degrees, and you subtract another 7 degrees, is then minus 59. For the transition altitude, we have 18,000 feet in here. Now, in the UK it is 6,000 for our departure, so we are going to put in 6,000, and we'll add 1 more feet. The reason for this is that if you're flying in VNAV, and you have an altitude constraint of 6,000 feet somewhere, and then your computer would have a transition altitude of 6,000 in, then the flight management computer would assume that you want to climb to flight level 60 instead of altitude 6,000. Now imagine this with a QNH that is, let's say, 20 hectopascals above standard, so 1033 versus 1013. Now, the airplane would assume that you want to level off based on an altimeter setting of 1013. However, due to the 20 hectopascals difference, it means that you have 1 hectopascal equaling around 30 feet. It means you have about 600 feet of altitude difference then, by which you could overshoot or undershoot the altitude. Therefore, for the transition altitude, we always add 1 feet, and in this example in the UK it's 6,000, and we make it 6,001. From here we go on to the fix page, and I'm using Sim Toolkit Pro here, which is a really neat add-on, and I have linked it up with the airport briefings of fellow YouTuber Blackbox711. So we go on the search here, enter Stansted, Echo Golf Sierra Sierra, and we're looking for our engine out standard instrument departure. So that's the routing that we would fly in case of an engine failure. In this case, we proceed on the track 223 to 20 miles and hold. Therefore, as a small reminder, we are going to insert Echo Golf Sierra Sierra /20, and that is going to draw us a 20-mile ring on our navigational display that we can use in case we have an actual engine failure, so that we don't have to look it up anymore where we want to go, but that we simply got the information available over here. From here, I'm personally always preparing the descent page already, so we're going to insert 250 knots below 10,000 feet. The standard value of 240 knots comes from the restriction in the United States where the 737 is being built, where it's 240 below 10,000. But in Europe, it's 250 below 10,000, or below flight level 100. Therefore, we changed this value since the airplane, or rather the VNAV, is doing a very good job in actually maintaining speed. Therefore, 250 below 10,000. Next we go on the forecast. Transition level in Dublin is flight level 70 for this one. We'll have to confirm it when we get there, but for now, we'll just insert what we are aware of. Going a little bit further down in the flight plan, we can also already find our destination QNH, that is 1014. And then we can also insert the wind information already. So we look here in the descent data block in our operational flight plan. We'll take flight level 310, flight level 200 and flight level 100. And the reason for that is that we then get some very nice data for pretty much all the descent. So at level 310 it's going to be 88 knots, 88 degrees at 29 knots. Flight level 295 degrees at 35 knots. And then flight level 100 is at 86 degrees and 31 knots. So, with all this information in, our FMC setup is practically finished. However, there is one more thing we can do, that is go to the Lex page, then set your navigation display to the plan mode, and then just step through all the routing that you have here to make sure that there is nothing wrong. And talking about nothing being wrong, we actually see something here where our route is slightly overshooting the turn on the departure. We can fix this by inserting a speed limit, So at the hotel point over here, we could, for example, put 220 knots or less in. And then once this routing is actually executed and the FMC starts calculating, you will see that this is going to give you a nice turn that's not going to overshoot. Talking about execution of the FMC, I have not executed it yet, since in real life, when you are preparing the box, you leave it unexecuted, and then only once the route check is completed as part of your briefing, you are going to execute the FMC. For the sake of flight simulation at this point, you can execute the route, and then it is going to start all the calculations over here. You see the data filling in, and then you can also just check it here. Now, this is probably an issue that's being caused by the beta right now, with the route not indicating correctly here. Well, that's something I'm going to raise with PMDG. Actually, it is something that PMDG is aware of already and working on, since we are expecting a new lateral navigation update for the 737 to be released at a point somewhere shortly after the release of the original airplane. So this is about all the setup that we're going to do, and this is basically your finished flight management computer. All that's missing now is the takeoff performance data, and we're going to cover that when we reach the point later in the tutorial. Thank you very much for watching. I hope you've enjoyed this, and once again I'm going to upload a second tutorial in which I'm going to show you some of the automated uplink features of this FMC. Thank you very much, and see you next time.